Welcome to the Struct Soft Center community.
Hello everyone, welcome back you all in this new video. In this video we are going to learn how to design isolated square or rectangular footing when it is going to be subjected to axial load as well as biaxial movement or uniaxial movement. So we are going to take the help of this spreadsheet for the effectively designing of this type of foundation in a short period of time. If you are going to do the design by manual approach, it will take hell lot of time. So to save the time, we are going to take the help of this spreadsheet, and for better understanding of the application of this spreadsheet, we are going to take the help of one reference problem, and with the help of that reference problem we are trying to understand the application of this spreadsheet. So without of wasting time, have a look over the problem statement. So the problem statement has given in the two parts. So one by one we are going to understand it. A rectangular column of size 230 by 600 in mm is transmitting a vertical load of 1350 in kilonewton along with the moment of 15 kilonewton meter about the major axis. So here in the figure you can see that the footing is going to be subjected to 1350 kilonewton in a gravitational direction through the column centroid, and there is a movement about the major axis, means the axis which is passing through the width of the column is 15 kilonewton meter, and there is another movement of 20 kilonewton meter about the minor axis, the axis which is passes along the depth of the column. This is what experiencing the movement of 20 kilonewton meter. The footing is to be designed for the materials as M30 grade of concrete and Fe 500 grade of steel. The safe bearing capacity of the soil is given as 375 kilonewton per meter square. The permissible settlement is limited to 25 mm. We have to design this foundation for the given data and the soil condition. This is the responsibility to do. And in the problem statement part B, what is given, the depth of the foundation from the ground level is 2.5 meter. It is what? 2.5 meter from the ground level up to the foundation base. The depth of the water level below the ground is 5 meter. The depth of water level from your ground, it is given as what? 5 meter. The unit weight of the soil is 18 kilonewton per meter cube over which it is going to be rested. The coefficient of friction is to be considered as 0.5. The service lateral load acting at the ground level is 45 kilonewton. So the lateral load is also acting on this foundation at the ground level is 45 kilonewton. It is the service load. We have to perform the stability checks for uplift, for sliding and for overturning. So basically in general case, for the normal foundation design we have given this data just to do the simple design when there is no need to perform the checks, stability checks. But if suppose you want to do the stability checks, so you need to have this data also. Depth of the water table, friction, everything you need to know. So in this spreadsheet you can perform the stability checks as well. This sheet is capable of performing the design, scheduling, detailing as well as performing the stability checks. Now one by one we have to do the steps for the purpose of designing. But before of that, let's try to understand how to use this spreadsheet. So here some guideline has given how to use this spreadsheet. So you have to edit the values only in yellow cells. Wherever the white cells are present, you don't need to do anything in that white cells. There is a green cells, that is the sign of the safety or safe design. There is a orange color cell that will define you the value which is close to safe. That is the suggesting cell. This cell will suggest to you what should be adopted. And wherever you are getting the red cell, that is the cell of the danger. Means you did something wrong, you had to correct that. It is the failure sign. Hope that you all understood how to use this spreadsheet. Now here we have to define the data that we have given in our problem statement. So in the problem statement, the first thing, as the sheet is asking, what is the SBC of the soil? So SBC of the soil, here it is given 375. So I am going to put here as 375. Next to that, what is the unit weight of the soil? So the unit weight of the soil is given in our problem statement as 18 kilonewton per meter cube, as you can find in your problem statement, is the unit weight of the soil. Next, it is asking depth of the foundation and water. So depth of the foundation from your ground level, it is 2.5 meter, and depth of the water from the ground level is 5 meter. What is the size of your column? 230 by 600. If any other size of the column is there, that you can define here, suppose 300 by 900 is the size of your column, so that you can define. So here my size of the column is 230 by 600. So whatever the size of the column you are defining, accordingly your figure is going to be updating here. So size of the column is, suppose I am going to define as what, 300 by 600 in mm. So as you can find here, accordingly the figure is now updating here. And if suppose the size of the column is 230 by 600, so accordingly the figure is going to be updating here. So based on your input data, your figure is going to update. Thereafter, what grade of concrete you have to use for the designing of this foundation? So we have to use M30 grade of concrete and Fe500 grade of steel. So I would like to define those things in this spreadsheet. So FCK grade of concrete, so whatever the grade of concrete you would like to use, you can use from here. So N30 grade of concrete, and drop down list is there for choosing the grade of steel. So our grade of steel is what, Fe500, that's why I am going to choose Fe500. Clear cover for the foundation, it is what, always you know very well, we have to define it as what, 50 mm. The diameter of the bar on a trial stage, we can consider it as what, either 12, either 16, either 25, whatever the diameter of bar you would like to use. At a preliminary stage you can choose that. So I am going to take it as what, 12. Thereafter, load definition. Here you have to set the definition of the load. So in our problem statement, here we have given that the axial load over the foundation is 1350 kilonewton, and moment about major axis 15, and moment about minor axis as 20. So both of the things here I am going to define. So 1350 kilonewton is your service axial load, and moment about major axis 15, and moment about minor axis 20. And one more thing, here it is given, that is what, the lateral load. So the lateral load in our foundation at the ground level is going to act with the intensity of 45 kilonewton as the service load. Here it is given in your problem statement as well. So I am going to put here as 45. In most of your cases there will be no any lateral load, so you can put this value as 0. Or even in most of the cases there will be no movement about major axis, you can put it as 0. In most of your cases there will be no any movement about minor axis, you can put it as 0. So whatever the thing is not given, you can ignore that, you can put the value for that particular cell as 0. And if the value is given in your problem statement, then you have to define it here. So this lateral force basically required to do the stability checks only. Otherwise it is not needed to be defined here. But in our problem statement we have to do the stability checks as well, for the uplift, for the sliding, and for the overturning. That's why I need to define it here as 45 kilonewton. Hope that you all understood these things. And you know, at the initial stage we have to consider the self weight of the foundation. So normally we are considering it as 10%. If you would like to change it, like suppose 5%, 7%, 8%, 9%, whatever you would like to do, you can define it here. Accordingly, self weight of the footing is going to be considered. So I would like to consider the 10% as the self weight of the footing, so that I am going to define here as. So it is a 10% of your axial load. So 10% of axial load is going to become 135 automatically. So here we are getting gross load and area requirement. We don't need to focus all of these things. We just have to look at what size of the footing is in requirement. So the width of the footing required as 1.81 in meter, and length of the footing required here as 2.18 in meter. But you know, this orange color cell will suggest to you the safe value. So it is suggesting that what width of the footing should be considered, what length of the footing should be considered. So 1.81. So I will try to take it as 1.8, and I will try to take it as 2.2. So what is happening? So it is intimating that your size is inaccurate, which is not safe, because maximum pressure is exceeding the limit of SBC of the soil. Actually the case is what? The maximum pressure should not be more than of your SBC of the soil, and your minimum pressure should not be less than of zero value. So it is safe, and this is what unsafe. So what I need to do? I need to increase the size of the footing. Footing size is unsafe. Here you are getting the status for the acceptance. So what I need to do here, 2.2 I have taken as the sheet is suggested, and thereafter what, here I am going to take it as 2. So whether it is safe or unsafe, yeah, it is not coming out to be safe. Your SBC is 375 and your maximum pressure is 360, which is less than of your SBC of the soil. Now you are safe. If I am going to further increase the size, then it is going to become more safe. So suppose here length I would like to consider as 2.3. Now this is finally the size I am going to adopt. So maximum pressure 344 and your SBC is 375, that's it is safe, and minimum pressure should always be greater than of 0. Then what? It is also safe. So if the values are safe, then it is showing by the normal condition white cell. But if it is failing, then what will happen? This is going to be shown by the sheet as red, means sign of the danger. You have to increase the size, and plus there will be no acceptance of the size. But now we have adopted the accurate size, adequate size, so that's why there is an acceptance. So hope that again you are understanding these all things. Now moving ahead, further calculation for the pressure, for the movement, for everything, sheet is going to take care for that. Okay, and it is finally calculating the design moment at a proposed section. It is what? Along the width of the foundation, it is 448.58 kilonewton meter. Along the length of the foundation, 356.81 kilonewton meter. This all calculation where the sheet has done accurately, and now we just have to finalize what depth of the foundation we should adopt. So here, as per the flexural requirement, the depth of the foundation is 221.09 in demand. So at least this depth we need to provide for the case of the flexure only. But for your kind information, the depth of the foundation mainly governs for the shear instead of the flexure. There are two types of the demands of the foundation depth. One is your flexural demand, second one is your shear demand. So normally the depth requirement we are going to be governed by shear demand instead of your flexural demand. So instead of directly using 221.09, I would like to go with a 500 depth of the foundation, overall depth of the foundation. So 3 times, as per the expert recommendation, the trial depth of the foundation should be taken as 3 times of the effective depth requirement for the flexure. So if you are going to take 3 times of this 221, 3 times, so it is coming out to be more than of 600. So here I would like to take it as 500 towards a conservative side. Okay, so that's why I'm going to define it as 500. Later on, if there is a need to increase the depth, then I will increase, otherwise I will keep it as 500. Now, area of the reinforcement required. So here the area of the reinforcement required as 2419 along the width and along the length 1917.34 mm square, the area of the reinforcement required. And what is the minimum area of the reinforcement required, that also given here. Now important thing is that what diameter of the bar you would like to choose. So here I would like to choose the diameter of bar as 16. Here I would like to choose the diameter of bar 20. Here I would like to choose the diameter of bar of 22. So whatever the diameter of the bar you are going to choose, the spacing requirement is going to be adjusted accordingly. But you know, as per our codal recommendation, the maximum spacing allowed is only 300 mm. You are not allowed to provide the spacing more than of 300 mm between the two bars. But most of the professional structural engineers, they are limiting themselves to provide the maximum spacing to 250 mm. Although your code is allowing to provide the spacing up to 300, but for the safety we are providing the spacing to a maximum of 250. Okay, so what to do here, the spacing is exceeding beyond of 361. If I would like to provide here a 16 mm dia, so accordingly the spacing requirement will be. But we don't need to provide this higher diameter of bars, just I'm trying to explain. So here 12 I'm going to choose, here also I'm going to choose the diameter of bar as 12. So if I'm going to use the 12 mm diameter of bar, so what spacing required? 107, 117. And guys, in normal cases we are not providing the spacing less than of 100 mm as well. Okay, so the spacing we are providing in between of 100 to 250. So basically, if here I have a chance to reduce the spacing to what? 100, because whatever the spacing is in demand, you cannot provide the spacing more than of that. Always you have to provide the spacing less than of that. So lower value by the round of factor of 25 mm, because 1 inch will equal to 25 mm. It is again the practical thing. So whenever you are going to execute on site, or the site is going to be executed based on your design, so it should be what? Easy to execute. So on site 1 inch will equal to 25 mm. So you have to provide the spacing with a round of factor of 25 mm. So that's why we are going to adopt the spacing as what? 100 mm. Otherwise you will say that sir, you can take it as 105 as well. So no, I am going to provide the spacing as what? 100. And here I would like to take the spacing of what? 100. You will say that sir, we can take the spacing as 110. So 110, that will also be correct, but for the site consideration it will be difficult to execute. That's why we are going to take it as 100. So finally provided bar is 12 mm diameter of bar at a spacing of 100 mm center to center, 12 mm diameter of bar at a spacing of 100 mm center to center. Got it? So provided percentage of reinforcement is going to become 0.226, 0.226. So as per the codal recommendation, the reinforcement to be provided more than of 0.12%. So in respect of that recommendation, we are safe. Now we have to perform the one-way shear check along the length of the footing, one-way shear check along the width of the footing. These two checks is needed to be performed, and there mainly we are looking at the nominal shear and critical shear. So maximum critical shear capacity is what? 0.35, and your actual shear is coming out to be 0.45. That's why it is failing. Fail, revise the depth of the foundation. And along the width of the footing, here what is given? The critical shear is 0.35 and your actual shear which is coming on your footing due to the loading is 0.5. So actual loading is more than of your capacity. That's again sign of the failure. So here sheet is intimating that it is failing. We need to revise the depth of the foundation. So what I need to do, I need to increase the depth of the foundation. Now finally I would like to provide the depth as 650. So now 650 is your depth of the foundation we are going to adopt. And guys, important thing, remember here, actual weight of the foundation is 5.54. Actually, when we are initiating the solution for this problem, we have adopted the self weight of the footing as 10%, because at that time we don't have the length of the footing, width of the footing and depth of the footing. To know the weight of the foundation, we need to have the length of the foundation, depth of the foundation, width of the foundation. If these three things you are having, then only you can calculate the actual self weight of the footing. But once you decided the width, once you decided the length, when both of the things has been calculated and depth as well, then you can calculate the self weight of the footing. So the self weight of the footing is 74.75 and by percentage it is 5.54 only, but we have considered as 10%, so we can take it into safety. Otherwise, if you will say that no sir, I will change it, I will make it accurate, so you can consider it as what, 5.55 or 6% as well. So I can consider here as what, 6%, and accordingly you can further proceed. But I don't want to change it, I would like to go with 10% only. Now again we have to look at what diameter of bar is required and what spacing is required. So I would like to go with 12 mm diameter of bar again. And what spacing is required? Spacing requirement is what? Here 145 along width as well, along length as well. So I am going to provide as what? 125 along the width, 125 along the length. So 12 mm diameter of bar at a spacing of 125 mm, 12 mm diameter of bar at a spacing of 125 mm center to center. Now here you can check for the one-way shear along length, along width. We found that provided depth is safe for one-way shear along the length, provided depth is safe for the one-way shear along the width. Now after checking for one-way shear, we have to go for the two-way shear check, or we can say the punching shear check. So here again we are going to see what is the nominal shear. So nominal shear is 0.779 and critical shear is 1.21. So again your design is safe for the punching shear or for the two-way shear, because your nominal shear is less than of your critical shear. So provided depth is safe for the two-way shear. Now finally guys, we are going to perform the stability checks. So sheet will take care about performing of the stability checks. So uplift checks, here is what safe again, because the factor of safety against the uplift check is 4.25, which is more than of your 1.5 limiting value. So it is safe against the uplift check. It is again safe against the sliding check. The factor of safety against the sliding check is 2.53, which is more than of 1.5, and factor of safety against overturning check, it is 2.03, which is more than of 1.5. So our design is safe against the all stability checks. And when your foundation is not subjected to lateral load, let's consider an example. I am going to put here as what? 0 value. So you can put it as 0 and there will be no any impact on all of these other design except of only the stability checks. So in your stability checks, the uplift check, it is applicable for every of the cases whether the lateral load is there or not. So here uplift check is what? Safe again. But for the sliding check, there is no need to perform the sliding check because the lateral load is not there. So there will be no chances of shifting of your foundation. And when there is no lateral load, again there will be no chances of the overturning. So that's why we don't need to perform the sliding check, we don't need to perform the overturning check. In both of the cases, it is what? Safe and not needed to perform when your column is going to be resting at the center of your footing. Now this is what the complete design. Again, as per the problem statement, I am going to put here as 45. Once you put the 45, automatically this check will be in active mode, and we are getting whether they are passing or not. So they all are safe. Now we have to look at the final schedule. So here footing number, or if suppose in group, so you have to choose the group 1, how many number of footings are there in that group. So it is a 1 footing, so you can put it as 1. And what is the length of the footing, what is the depth of the footing, this all where sheet has referred from your previous adopted values and giving the final output. And the reinforcement along the width of the footing, here it is updating. The reinforcement along the length of the footing, here it is updating. So everything is now present here. Now I have to prepare the schedule. So this is your schedule sheet. Come back, so here go to schedule. So you are in schedule sheet, you have to come back to your design sheet, then click over this, you are coming back to your design sheet. Now I have to send this design report to my schedule sheet. So you just have to click over the send to schedule. Once you click over the send to schedule, so now this data is available in your schedule list. When you come back to design sheet, then if suppose another design you have done here, then you have to take in the group 2, and suppose number is what, 3 number of footings are there in this group, then you have to click over this send to schedule. So that is what going to be updated in your schedule list. But if you feel that last entry is done by mistake, then you can click over this clear last entry. Once you click over the clear last entry, so now in your schedule list you will find only 2 entries. So I would like to come back to design again, and if your project is completely done, then you can simply click over the clear all. Once you click over the clear all the entries from your schedule is going to be what, cleared. So guys, you don't need to go to your schedule again and again by putting it manually. With the help of this sheet, you can prepare your schedule automatically by just clicking over these buttons. And as per your design calculation as done by the spreadsheet, your detailing is also going to be updating here. Detailing for the reinforcement, so it is along the width, so width is 2 meter and depth is what, 650. And what is the length? Length of the footing is 2.3 meter, and this is the width of the footing, 2 meter. Along the width of the footing, 12 mm diameter of bar at 125. Along the length of the footing, 12 mm diameter of bar at 125. If suppose you are going to make any change, suppose along the width you are going to choose the 100 mm spacing, so accordingly here it is going to be updating along the width 12 mm diameter of bar at 100 mm center to center, along the length 12 mm diameter of bar at 125. So whatever the things you are going to choose while designing it, it is going to be updating in your detailing, and it is going to be updating in your schedule. So in respect of your design, everything is going to be prepared. Hope that you all understood how to use this spreadsheet for designing of your foundation when the foundation is going to be subjected to axial load as well as biaxial movement, and we have taken the help of this problem statement to design this foundation. Thank you all for watching this complete video till its end. If you like this video, don't forget to like, share and subscribe. And please share this video with all of your friends, those who are related to civil engineering and structural design field. Thank you.